Good afternoon. This is, well, yes, this is Comp 422 and Comp 620 Information Privacy and Security. And we're going to talk about cross-site request forgery for a while, and then we're going to review for the exam on Wednesday. We'll talk about that a little later. Okay, cross-site request forgery is one of those big attacks that's very prominent in the OWASP list of the top 10. It has several names: one-click attack, it's XSRF sometimes for cross-site, or CRSF, depending on how you spell cross. If it's CSRF, it sounds like CSRF, but okay. The whole concept is that you have multiple websites, and they're sharing cookies, and they're making requests to another website that you didn't expect to be made. Okay, that's okay. It all depends on cookies. You go to a website that you trust that gives you the cookies that you normally get, and so your browser has the cookies for this. But while you are open in the browser, you have another tab, and that other tab goes to a different website. Well, the other tab can share some of the material that's on the cookies. It can send a request. So if the application in the second tab forces the request sent to the original website of the first tab, it will have the cookies. Since the cookies say I'm logged in, or something, you might log into your bank, and then an application on the other one can send something to the bank, and it will say you're logged in. So you transfer your money to me. A big event with cross-site request forgery. Of course, it's cross-site. You have two websites involved. It relies on the first website, has a trusted relationship with the user. They've got cookies, you've already logged in, you've identified yourself. But then the second website is going to go out there and take action, do something to that first website that will cause something to happen that you don't want to happen. And as I say, it involves HTTP requests that have side effects. Let me say something first about side effects. There are two primary commands in HTTP. There's the get. We talked about the get. You go out there and you say get a page, and there's put. Put, which means put this information out there. Typically, if you are sending information to a website, it's a put request. If you are getting information from a website, it's a get request. The general philosophy is that a get request should not cause any changes to the website. It's a read-only get request. Put requests send something up there and make a change. So if they make get requests, systems have a different set of rules. They'll say, well, this shouldn't make any changes. It doesn't matter what I say because not any change. A put is different. There are several ways to help minimize the impact of cross-site request forgeries. There's the same origin policy specified on the cookies and other information that something's the same origin. That is, same origin means everything has to come from the website where it originated. So if you came from www.acme.com, that's where the web page was, then other files, so you're downloading images, they also must come from that same website, www.acme.com. You can't go out and get them from someplace else, because otherwise you can pick things up from many different websites, and most things do. You see all these advertisements with pictures, those all come from advertising websites. They don't come from wherever you're going. So if you go to A&T's website, A&T's websites, there are no secrets in this world. When you go to A&T's website, it tells Google, it tells Facebook, it tells Twitter that you are there. Now, we'll talk more about that when we get around to privacy, but there ain't no privacy in that website. So it goes out to many different places. There are certain requests, like There's one called XML HTTP request. That is a function you can call in JavaScript. It's a very commonly used function for communicating with the server. If you have a web page that's going to send and receive JSON formatted files to the website and back, they're going to be sent by the XML HTTP request function. It will only send things to the server where you originated came from, which is a big security improvement, because if you start sending files to any place you want to, it's not going to be very secure. You can, as I said, access other websites. A particular place would be images. You can get pictures from anywhere. And frequently, like when I make a website, I don't bother to copy the picture from some other website and put it on mine. I simply direct the browser to go out to wherever the origin was and get it from there. I don't know if I'm okay with the copyright laws, but I just think in my mind that if I didn't copy their file, if I just kind of pointed you to it, then it should be okay. I don't know if the lawyers think the same way, but that's how I think about it. So I just point my links. When you want to get an image, I specify the source. And here's an example where you can see they're going out to this website to get a picture. Now, when they go out to get a picture, normal links just go out and say, I want this picture. And it returns that image file to your browser, which displays it in the box where it's supposed to be. But it could be a specially crafted web page could grab information from that's available in JavaScript. You can get the user ID, whatever information it knows. Cookies are a good one. And other information stored in JavaScript at that time, and send that along with the request for a page from the or picture from the website. So in the example here, we're sending other information along that will be sent in the URL request. And you may not want to send that stuff. Yes, we have a question.
See, this is up what we can you change it to like 53, for example?
Yes. In this case, I'm just getting an image because that's the usual picture you get. You could have other media like videos and stuff and get them from someplace. To be honest, I'm not very familiar with audio. Obviously, it can be done because I've had websites talk to me, but I haven't done that much myself. But yes, that can be done. And the same thing, you can, within that request to the other website to get the audio or video or image, send it some other information. And if the other website, in this case, nastybad.com, is designed correctly, when you make the request, it's looking to get that additional information about you, passwords, cookies, other stuff that might want to acquire. And then these will be made by GET requests, because in theory, GET requests don't change anything. They're not sending information, even though you may have to frequently send information to get the right data you want. It's a GET. It's not supposed to change the server, but it could. Here's a bigger example, full example of getting a picture. In this particular program, you can copy and paste this, and it works. It's looking for a picture cowhazard.jpg, and you go out to that website. It picks up that picture and displays it on the screen, and then it asks you to type in a picture, and you can type in any place, HTTP : any place you want to, and it displays that picture if you select a proper picture. So it just shows that you can pick pictures out from any place on the web. You can specify, if you don't specify a complete URL, you can just get a picture that's on your computer, but it could be a picture any place on the web that you specify. You can, in addition to just getting pictures, there are forms you fill out. You're normally in a web form, you see little blanks, you fill out, press the submit button or whatever the button says, and it sends this thing off to the server. Yes, you see several of those in the examples we've had where you type in the user ID and password, press a button, and it sends it off. That's just a very simple form in HTML that sends the stuff off. You can specify where is it supposed to send this information when somebody clicks submit. Typically, it would be on the same website as where you downloaded the page, but it doesn't have to be. You can specify a different website. That's the key to the problem. If you have another website and you want it to do something for that other website, it will do that, and it may have access to cookies. Here's an example. Say I log in to my bank, and I've entered my user ID and password, and then on the same browser, open another tab, and I go out to some other website, probably one that I shouldn't go to, and that other website has a form, and it submits the information. Now, forms typically, the user types in some information and presses enter, but it doesn't actually have to be that way. JavaScript can fill in the information and send it for you. You may not even ever see it on the screen. You can hide it on the screen, send it off just by JavaScript, because there are possibilities to have hidden values in a form. But the form may have all hidden values, and submitting it may be something that can be done through JavaScript. So if the form has all hidden values and it's submitted through JavaScript, you never see it, but it's done. It's sent off to the server. So if I log into the website, then go to this other website, that's the evil bad website, perhaps comp422 comp620.online. Ooh, don't want to go there. And click on it. It can send a request off to the bank. It will have all the login information. And it can say, oh, yeah, transfer money to that guy, which is not what you want. Now, I've been experimenting with this myself. I went out there and tried this several different ways and used the burp proxy suite to find out what's going back and forth. With my experimentation, didn't send cookies when I went to get an image. It did send cookies when I did a form. So if I did the form thing, it would send the cookie. It didn't do it for images. If you use a different window, as opposed to a different tab in your browser, it doesn't work. It shares cookies within multiple tabs of the same browser. If you open up another instance of the browser, another window, then it doesn't share. And of course, if you use a different brand of browser, so if I'm using Chrome and Microsoft Edge, they're not sharing anything. Oh, heaven forbid, they don't want to share and talk to each other. So they don't share any cookies. The key takeaway one of these is for regular users. If you're on a website that has sensitive information, particularly something dealing with money, if it's Amazon where you're buying things, or your bank where you're using money, when you log out, close the page, close the browser. Don't go back and use that same browser without closing it if you're going to go to another website, because it may have access to cookies that you don't want to have. So when you log out, close the browser. I know that's going to be hard for people like my wife who have 24 tabs open on the browser. You know, you could, there is a close button, but yeah, so it's wise to close the browser when you log out of a sensitive site. Another thing I want to point out, several of the attacks we've mentioned today involve sending an email to somebody and having them click on it and going to a malicious website. They might not know they're going to a malicious website. Here is an example where we have a URL, www.warmandfuzzy.com. But that may not be where the link goes if you click on it. There are two aspects to a link on a web page or an email. One is what you see, the text that you see. The second is what URL you will be executed when you click on that. It could be an email, it could be a web page. And they don't have to match at all. They can be completely separate. And so one that goes, www.warmandfuzzy.com could have something below it, like, my example here is spidersandsnakes.com. So you click on this, you don't go to Warm and Fuzzy, you go to Spiders and Snakes. Unfortunately, nothing catches that. Nobody gives you any warnings that this is not working. And I suggested on multiple occasions to Microsoft that maybe they should. One of the reasons they don't is that in several places, there'll be email modifications that will change your email so it goes to a system that validates the URL. Here at A&T, at least for faculty, I don't know if it happens for students, but I hope so. If I look at a link, I'll see it goes to some site that checks that link. So anytime I click on a link in email, it doesn't go directly to that web page. It goes to the check site. The check site looks at where you're going, says, oh, yeah, that's okay, and then redirects you to that site. Or if it says, oh, that's a known hazardous site, it will send back a message saying, you don't want to go there. Often providing you with the button says, well, yes, I really do want to go there. I don't care. But it usually will check, tell you that it's bad. And because every link on your email or website or on your email have been modified, then it's hard to do anything that checks that. Another place where you might find modifications is QR codes. Everybody's got these little QR codes popping up. You go to a restaurant, they don't want to hand out menus. They've got a QR code stuck to the table. You're just supposed to open it up with your phone and order that way. That's really nice. People have figured out, though, they look at that QR code, they get the tape measure out, see how big it is. They go home, they print up their own QR codes for their website, little adhesive, stick it on, they come to the restaurant, snap it on the desk, put it on top of that old QR code. And now when you click on it, it goes to their website, which looks just like the restaurant's website, gives you the option to pay for it too. Just click here, order your stuff, and pay for it. Well, when you're paying for it, you're not going to the restaurant, you're going to their site. Once they collect the money and run. So it's sometimes wise to watch out, where is this going? Particularly if it doesn't look like the web page is going to where you expect it to go, don't go there. Watch out for going someplace that is not in this country. If you are going to a restaurant downtown and they want you to pay, they're not going to be taking payments from a .ru Russia website. It is not going to happen. So if they're redirecting you to that, it's probably not correct. Okay. I got a question here. Let's see if anybody's paying attention. Where are the polls? Works and so I can, oh, his finger on it. Okay, there we go. And I think we got it. Oh, got it all right. Okay. Yes, I like, B is a good answer. Although I think A and C are also true, which would mean D is all the above. As I mentioned earlier, my experimentation didn't look like it was sending cookies for that. But I couldn't find any documentation that says doesn't send cookies. And they talk about cross-site scripting. They talk about the threat of sending cookies. But all my experiments show it doesn't send any cookies. And the same origin policy, which we didn't talk about, does also prevent that. Okay. Oh, I didn't think we mentioned that. All right, moving on, though. We will just move on. Okay, yes, I guess I hadn't talked about how to protect yourself. There are several ways to protect against cross-site request forgery. There are a bunch of frameworks. If you go out, generate web pages, most people, except for me, most people don't generate them from scratch, just type in the HTML. They use tools, and there are a lot of tools. Several tools have built-in protection for this, that they have code that's automatically generated for you that will protect against cross-site request forgery. Non-cookie tokens, we'll talk all about these, and the same site cookie option. Okay, the the protection systems, again, there are several, all sorts of these. They're all built-in protection systems. Non-cookie tokens. Now, we're talking about cookies, which are information that is sent along with the web page that users don't see. It's sent in the header, but you can also send additional information that the users don't see. You can have hidden values in a form. If the user is sending a form, you can have hidden values that are sent, and these can be checked. Okay, imagine you have a form that asks you to type in information. The website creates, excuse me, backing up. Assume you've already logged into this website. Now it's going to send down a page to you. It modifies that page for every user. This is pretty simple. With PHP and HTML, it can just make a separate page for everybody. So even though it looks like the same for everyone, a small section of it is changed. It will send in a one line that's changed in there. On the form, it will say the random value is different for every user. It can just take something it knows about you, hash it, put the hash value in there. No way you're going to go back and find out what it is. Because even a very simple SHA-1 hash is 20 characters long, it's hard to guess. So this value is sent back whenever you send in something from that form. Maybe you fill in the values in the text fields, press the submit button. It's not only going to send what you requested, but it's going to send this hidden value. And the hidden value goes back to the server. The server says, oh, is this the value that I put on this web page? If it is, okay, this is the web page I sent. But if it's not, then this is not the web page I sent. Somebody's modified it, or somebody else is coming in through a different avenue, which would be cross-site request forgery. The header, the HTML header, you have several values in it. One of them is origin. A post tells what website generated this request. Refer. Whenever you click on a link and go to a website, it tells the website where I got this request. So if I go out to www.acme.com and I click on a link and it sends me to www.widgets.com, the widget website will get when it gets the request, it says, oh, you were sent here by Acme. Advertising companies like to know that. They like to know where the request came from, who they're going to pay. But it also gives the sites an idea of where things are coming from. For the origin and where you're from and the refer are not the same, you may have a problem. I might note that refer is null, it doesn't send it. If you typed in the URL, which if you look at it, you go press your keys www.acme.com, and it doesn't know where it came from. But if you clicked on a link from some other page, it tells you where it came from. So if things don't match, you can go, this is not coming from where I thought it was. I wanted to point out the cheat sheet series on OWASP. OWASP.org, again, is the website for web security. I forgot what OWASP stands for, but it's a web security website. It has lots of information. And in particular, this is the index. This is the header for a whole bunch of them. You click on the header. Usually at this point, you can click on the alphabetical order of them. It has many, many links for particular problems. You can click on them and see what do you do to save yourself in this situation, or how to prevent these problems. Okay, that's all I had to say about cross-site request forgery. Anybody questions? Anybody online? Okay, then, having finished cross-site request forgeries, let's move on to a review. If I can get there. All right. And share my screen. You don't want to look at me, for Pete's sakes. Okay, there we are. Exam 2 review. Yes. You are here Monday. It is Monday. 2 days from now on Wednesday is the second exam. And then next week from today, is the last day to drop a class. Now, for most of you, that doesn't make any difference. There is a very small number of students who are doing pretty miserably. And if they do miserably again on the second exam, then they may wish to consider dropping the class. Particularly if you're a graduate student should never, ever get an F, because if you get one F, it's all over, you're done. Okay, but that's not going to be. I will sometime between Wednesday and Sunday afternoon, or at least before class on Monday, I will be sending everybody an email. And the email will include a summary of all your grades, both exams, the assignments, and then you'll know how well you did. I'll give you your average grade, what your score is, and also how well you have to do to get the next better grade. If you okay, so that'll be nice. So everybody will know where they are. Most people just look at it. Yeah, I got what I thought I got. Others, if a small percentage of the people, they want to go, oh, it's time to jump ship and get out of here. Okay. The exam on Wednesday will be like the previous exam in the sense that it will start at 6 a.m. and go to midnight. This time, it's really going to start at 6 a.m. I had a problem last time, but it will really start at 6 a.m. this time. I know what I did wrong. All students, those of you who are here in the live studio audience, those of you online, those of you who watch by YouTube, it's all going to be online. You've got 18 hours. It will not, of course, take you 18 hours to do the exam because it's a web-based exam. I'm not watching you, so it's open book, open notes, open web, open AI if you need to. But this time, any response to a question must be no more than 5 sentences, 75 words. Long responses will be penalized. So if you go out to ChatGPT and ask it the question, I already have, so I know what it answers. Most of them don't give really good answers. But if you do that, you have to summarize it. You just can't copy and paste, put it in there and say, oh, I'm answered the question. That isn't going to work. Because if it's really long, it's going to cost you a lot of points. I don't know if I'm going to take 1 point off for every word over 75. I don't think so. But we're going to do something. I'll talk with my TAs and we'll come up with some draconian measure that if we see long responses, it's going to cost you some points. So yeah, you can still do that, but you have to read it, understand it, and summarize it. Okay. Questions about the technical aspects of the exam on Wednesday. Now, the exam will cover these topics. It will cover topics since the first exam. There'll be no questions on this exam directed towards the material on the first exam. On the other hand, you'd be wise not to have forgotten the stuff in the beginning of the class. It kind of builds, and there are some aspects of this that rely on cryptography. And if you've forgotten how cryptography works, it could be challenging to you. Okay. I will go over some of these topics, but this is what's going to be. I just went down this schedule for the class, picked up all the topics, and there they are. Very little of the material we've covered since the first exam appears in our textbook, which is kind of a problem with the textbook. So if you really want more information, I recommend Wikipedia. I looked at Wikipedia for all these topics. Works pretty well. Some people don't like Wikipedia, and if you're doing research, it's not the end, but it could be the beginning of searching for things. And people say, well, yes, you can modify Wikipedia. Anybody can modify Wikipedia. How do you know it's true? Go ahead and try to modify Wikipedia and make something false. It's not as easy as it looks. All right, digital money. Central bank digital currency, CBDC, is the concept of a country having digital currency. The United States is looking at it. They are the Federal Reserve and the executive branch are both looking at what it would take to make a central digital currency. Hope they spell it correctly. I didn't. Okay. There are some in Congress who are dead against it, but sometimes there are people on one side no matter what how good whatever the other side says, they're against it. So, but we're not going to go into that. Yes. Yes. It's a central bank. In the United States, the Federal Reserve is our central bank. Most countries have a central bank. Of course, there are issues. There are pros and cons, like anything in the world. If we have now, of course, what we're looking at is having something. I hate to say like Bitcoin, because Bitcoin is wild and crazy and very volatile because it's not pegged to anything. Bitcoin, the value of Bitcoin is whatever anybody wants to pay for it. That is not the intent of a United States digital currency. It would be a digital representation of a dollar. And it would be tied to the US dollar, tied to folding money. Same thing, just like a credit card. You buy something with your credit card, you're not using folding money or coins, but a dollar on my credit card just means the same thing as a dollar bill. So they want to make low cash. The credit card companies probably aren't wild about this idea because they make billions of dollars doing this sort of stuff. So they want to take out that. One of the concerns is that it costs a lot of money to transfer money outside of the country because that's passed through third parties. If they could take the third parties out and one country transfers money to another country's central bank, it could become a lot cheaper. Greater access to the financial system. A lot of people out there don't use banks because banks are expensive. Well, they're a very good deal if you have lots of money. If you have wads of money, the banks really start to listen to you. If, though, you don't have much money, the banks don't. Sorry, opinion here. It doesn't appear that banks really care about you if you don't have much money. They charge fees left and right. I've had money in my life and I've had lack of money. And it seems like when you don't have much money, the banks can really kick you around. You know, you accidentally overcharge your account, and then the merchants will charge you for an overdraft. The bank will charge you for an overdraft. Now you got a huge collection of fees and you don't have any money. That's why it was an overdraft. Yes. But go ahead and put $100,000 in your checking account. The banks behave differently. Anyways, I'm sorry for the editorial, but yes. But it will, if we had a central bank to do that. One of the reasons that some of these countries have gone to Bitcoin as their financial currency is because these people don't have banks. There are very few banks in that country, but everybody has a phone. And they can use their phone to access Bitcoin and sell things or buy things with their phone. And so now everybody has access to it. Boost economic growth, which no politician can propose anything without saying they're going to boost economic growth. I'm surprised they didn't say they won't create jobs, but and one of the big reasons is they want to make sure that the United States is the center of international currency. The US dollar is kind of the bedrock of currencies in the world. People base things in the US dollar. The euro is also out there, but many other countries view their money or base their money on the US dollar. Yes, I have been to if you go to Bahamian dollar, even though they have their own dollar, it's worth $1 US, so they say. I'm not sure how they maintain that, but I'm not an economist. So. Now, concerns about the whole thing is stability. Make sure everything works and that $1 is always worth $1, and that somebody doesn't do something really bad to the system and suddenly flood the system with counterfeit digital money and make it all worthless. And that would be really bad. And protection of sensitive data. There's a double-sided problem here. You don't want the terrorists and the drug dealers and the arms dealers to go out there buying and selling things with your private digital dollar. On the other hand, you don't want everybody to know what you're buying with your digital dollar. So it's difficult. questions about this? Okay. Secondary goals, of course, it should be avoiding environmental concerns. That's thinking about Bitcoins. Bitcoins consume vast amounts of electricity, more than many other countries do. All the electricity to create Bitcoins, I think is more than Sweden uses all by itself, more than Argentina. It's a huge amount of electricity. And of course, you want it to work well, a good customer experience. And as I mentioned, they want it to be as sound as using regular cash. Okay, that's digital money. SQL injection. We just had the SQL injection on the last assignment. Hope everybody got that down really well, because there will be an SQL injection question on the upcoming exam. There's a question about that.
I had a question about that. So, I mean, you said that Bitcoin is private for all transactions.
Bitcoin maintains security, and they don't want anybody to know who bought or sold anything. Now, that's not 100% true. The FBI seems to be able to tell where things are bought and sold. I'm not exactly sure where the flaw in the system is, although it appears to be in the wallets that people use to buy and maintain their Bitcoin collection. But the Bitcoin system makes a transaction, deletes money from this numbered account with no name on it, and puts it into this numbered account with no name on it. And it's assured that that account has that transaction has occurred, and it can't be undone, and you don't see the names on it. So that's why it's the favorite for ransomware and people buying and selling truckloads of ammunition and stuff like that, which they don't want traced. Yes. I'll tell you that the answer to these questions in particular are in the slides. I made sure that, yes, when I'm making the exams and making my slides, particularly making the review slides, I make sure I have the answers there, so nobody can say, oh, you didn't talk about that. Oh, yes, I did. Once upon a time, somebody told me, oh, you don't have to go to Dr. Williams's classes. You just go to the review session, you'll learn everything. So, but I don't believe that. Don't pay any attention to what he said. Okay. All right. SQL injection. Here it is. The thing to remember in SQL, if you have a character constant, if you say name equals quote Ken Williams, it has to be in quotes. It has to be inside quotes. So when they take the input that you type in, like a user ID and password, it puts quotes around it. So if we look at the select statement, there's double quotes and single quotes. Double quotes are used to represent a quote string in public PHP on the server. So on the server, it says select star from login where username equals single quote. The end of that string is concatenated with the username. The period is concatenation in PHP. Then a second string here that starts with a single quote. So the username that you enter will be surrounded by that quote. And password equals quote, and the double quote, that's one string. And the password concatenated with a quote, a semicolon. Oh, so when you type in for a password X quote, or quote A equals quote A, note there's no ending quote. When you concatenate them together, we'll assume Alice was the username. Alice is always doing this, or it's Bob, that it's put in here, and that X quote is there. Note the quote before the X comes from up here in the string, and the quote after the A comes from up here in the strings. So those quotes are going to be surrounded by the text, so you have to make sure that you don't put those quotes in. A guiding rule for most SQL injections is you want an even number of quotes. If you have a odd number of quotes, then you're likely to be generating an unmatched pair of, parentheses. Like any programming language, if you unmatched parentheses, unmatched quotes, it's going to be a syntax error, and that's what you're going to get. Syntax errors, that sort of stuff, often show up as server error 500 or server error 403. The server error 403 says forbidden. I have no idea why forbidden shows up, but that seems to be a popular error if you do it wrong. Yes, sir. Yes, concatenation is taking one string, sticking the other one to the end, and another to the end.
So in this case, we're sticking X with the password.
Yes, we'll assume that the variable $username has Alice in it, and the $password contains this clever little string we have here. And so when you concatenate them all together, it comes out to the select statement with the password is quote X or quote A equals quote A. Now the trick with SQL injection is somewhere you have a statement that's always true. If you remember, on any side of the or, if one side is true, then the composite is true. If you have A or B, if A is true, it doesn't matter about B, it's going to be true. And the opposite. If you have A and B, if any one of them is false, the whole thing is false. It's same. You learn that as freshmen for Java, Python, C++, works the same way for all of them, and for SQL. So when you have this true statement where A equals A, that's going to be true. And the whole thing is we're trying to make this statement find something. We're trying to go out and find if this username and password is in the database. If we come back because we found something, because the SQL statement matched something, oh, it must be there. If you fool it by saying something that's always true, it will always find something, and therefore it'll always think you've entered the correct password, and it will log you in. That, of course, is not what you want.
The dots are PHP's way.
That is correct. And the periods in PHP means concatenate. Not to be confused with JavaScript, where the plus means concatenation. One of those language developers somebody should have explained carefully to them, but they didn't do it that way. All right. Now, sometimes you don't need quotes. Let's look at this one, and we're going to enter a PIN, a numerical password. And pins are numbered. In SQL, you don't need to put quotes around numbers because they're numbers, just like in Java, C++, Python, where you have to put quotes around a character string. You don't have to put quotes around numbers. They're numbers. And so same thing with numerical, just put the numbers in, no quotes. And we'll assume that 0 is an even number. So yes. And you can see here, if you entered a password or a PIN, it's put in the $PIN variable, that when you concatenate it all together, it's PIN equals 1 or 2 equals 2. Well, yes, 2 equals 2 is true. So that's true. So the whole thing's true. So it matches, and you're in. A dash, two minus signs right next to each other, is the comment delimiter in SQL. Everything after the 2 dashes is ignored. If you're a programmer, same thing as // in Java or C++. It just means the rest of the line is a comment, ignore it. That's often useful in SQL injection because there may be things after where you're going to enter the password that you might want to. There's other clauses we haven't talked about in SQL because this is not an SQL class. So you could say select star from table where password equals this order by, and that means sort it by this. Well, we don't care about the rest of the stuff, particularly if you're adding things like drop table. So you might want SQL to ignore everything after what you've entered. So, and it was a semicolon, which is the end statement for all SQL things, just like Java, and then put dash to say ignore everything else. It's just a comment. Remember, one of the protections for SQL is that MySQL, one of the very common free ones, doesn't allow multiple statements. So you can't do that drop. Yes, Dixon, there's a question.
Yes, I have a question. So when you add the two dashes on the end, is it similar to like if you're creating like a multi-comment comment or a single comment, or is that how you usually end with a semicolon and two hashes?
It'd be like a single comment if you use Java or C++, you go // and then everything to the end of the line is a comment. Now we're not talking like / asterisk and then a multiple line comment. No, we're talking about just one line. Because we're only entering one line, we're making one character string, giving it to the SQL system and saying, do this. Did I answer your question, Ms. Dixon?
Yes, sir, you did. Thank you.
Oh, okay. Any other questions? Actually, a couple of hints.
I'll wait till you.
Okay. Punctuation is important in this stuff. It's got to be really picky. You got to do it exactly right. Again, even number of quotes. Text constants, remember, always surrounded by quotes. Usually use single quotes. And numbers do not have quotes. You had a question, sir.
I had how about the last one?
Excuse me, back last one. Oh, I think
Numerical skill projection. Okay. The next
this one.
Yeah, it's good. I mean, I would say comment. Okay, so on the bottom you had created it, and in green there's 3 quotation marks. I get the one that's for the open.
Oh, okay. Yes. I put those in green because those don't count. Those doesn't matter what it says because it comes after the dash dash. Because it comes after the dash dash, it's going to be completely ignored.
So let's say after dash dash, there's like some other line, that other line of whatever input.
Right. Anything that comes after the dash dash. So if you put your password or your information in the middle and you don't want it to interpret the end, you just put the dash dash. And even though it's in the string that we give to SQL, SQL doesn't pay any attention to something past a dash dash. In the real world, they're used for comments, where in SQL, you might have an SQL program. People are doing, you put comments so people know, human beings will know, what are you doing here? But in this case, it's not for humans to read. Okay. Anything else about SQL injection? Then briefly, we talked about steganography. Steganography is hiding things, putting information someplace where you don't see it. It's not a really good form of security. It's security through obscurity. You're hiding something, but it can be used with encryption so that not only do people not know what you're sending, they don't even know that you're sending anything. So it's another layer. Turns out it's pretty darn easy to do. You can hide things in many different ways. We talked about storing text into images. I did that because you can store a whole lot of text in a picture. A picture's worth 1,000 words. Oh, it's worth more than 1,000 words. You can get a whole. I easily stored the whole syllabus for the class into that picture of a dinosaur. You can just, and to the human eye, you can hardly notice it. So, what do you do about that? There are a couple of things you can do to try to produce it. I don't mention it in the slide, but if you're going to hide things in the least significant bits, what was like the rightmost bits, the ones that make the least difference. When I say least significant bits, I mean, if you have a number, say 128, you can change the smallest digit until it goes up to 129 or down to 127. Or you can change the big digit. So it becomes instead of being 128, goes to 228 or down to 028. Well, that makes a big change. People will notice that. If you change the color, and we have a 1 byte at 256 different values for the color. Maybe you change it from 128 to 129 or down to 127. The human eye hardly notices it all. So that's what they do. They store that least significant bit. They are changing that bit to the signal that you want. Now it becomes that bit is no longer following the normal random or non-random probabilities of the picture. If you look at the picture, a true picture with nothing in it, the least significant bits follow a pattern. If you have a long background of gray or something, then all these bits will be very similar. Whereas if you're putting steganography in it, you'll find the bits change a lot. So you can go, oh, something's funny about the least significant bits in this picture. And you can recognize that. People do a lot of work with probabilities and statistics to analyze this and say, it doesn't look clean to me. There are ways you can clean things up. One thing about a picture is you can just imagine displaying, if you have some text or a document, you just want it to be clean. You can display it on the screen, capture the screen, take a screen capture of that, and then use text or image to text recognition, character recognition to recognize the characters. And that should be clean because anything that was hidden in there isn't going to be found. I thought that was there are other ways to sanitize the images. All right, networks. Real quickly on networks. This is not a networks class, and we won't have things on the network. It is not an HTML class. We won't have things on HTML, except in those cases where they impact security. So let me talk about the security issues of the networks that we mentioned. I mentioned that there are 3 types of names. There are internet names, something like www.ncat.edu. Then there are internet addresses, which are in Internet Protocol version 4. They're 32 bits. They're written as 4 decimal numbers separated by periods, numbers between 0 and 255. That's it. And in IP version 6, there are much bigger addresses, 128 bits, and they're usually represented in hexadecimal with colons between them. And then there are MAC addresses, so hardware addresses, such as Ethernet addresses that are used. Those are the addresses that the hardware recognizes. So if you send a packet from one machine to another, if you want the other machine to realize that it belongs to them, you have to have the proper hardware address, because your Ethernet card doesn't care about internet names. It doesn't care about internet addresses. It only knows whether the packet matches the hardware built-in address that it has. So you have to map between them. Okay, to go between internet addresses and hardware addresses, we use the ARP protocol, which is real simple. It just broadcasts a message and says, who's got this address? And the machine with that address sends back and says, it's me, here's my hardware address. Yeah, simple enough. And since it's only used on local networks, broadcast doesn't have to go very far. It just goes in the local network. Everybody gets it. Everybody ignores it except for the one machine that has that address and sends it back. Good enough. Unless, of course, another machine sends back a reply. You send out this request, and then a malicious machine waits a few milliseconds past the true request and sends its own request. Says, oh, I'm that. Because often you're looking for the default gateway. How do you get out of this? This is my local network. I need to go out onto the internet. There's a gateway or router that goes from your local network out to the big internet. And so every packet that goes from your local network has to go to the router, and the router sends it out on the internet. So first time you turn the machine on, it's going to go, oh, where is this router that you speak of? And it will do the ARP to find the router. That's when the malicious machine will say, oh, I'm the router. So your machine thinks that malicious machine is the router. It sends all the packets that go out to that malicious machine. And the malicious machine can look at the information, save it, do whatever it wants to, modify it, and then forward it on to the internet. So it looks like it's working to you, but you're getting all the information. What can you do about this? Well, on your computer, whether you have a Windows, a big server, or whether you have an Apple, there is a file, which name I can't remember at the moment, but there's a file of addresses that you can put there if you want to and say, okay, don't bother looking these up. Here they are to start with. And you can make them read-only. It says, you never change these. And so it reads those in, when it first boots up, particularly you'll put your router address, hardware address for the router in there. And so it doesn't bother ARPing for the address, and it doesn't accept any other requests. There are now more secure protocols for doing this. Internet Protocol version 6 has a much more secure system. When they came out with version 6, which obviously, by the way, was after version 4, nobody knows what happened to version 5, but version 6, they knew all the problems of version 4, and they worked hard to avoid them. Okay, so that's our protocol. Internet names are converted to internet addresses through a domain name server. That's just a server that knows a lot of names. And you send a request saying, what is the internet address of this machine? And it sends back a packet that tells you what the internet address is. Easy enough. Unless, of course, there's another machine out there who's listening, and you send the request to the domain name server. It responds as quick as it can with that response. So you go, oh, this is where it is, where it's a false response. It's going to send it off to a malicious machine. If you can get there before the regular domain name server does, particularly if you're looking for a address that your domain name server does not know initially. They might have to go out and ask around the web to find this, which might take some time, milliseconds, but take some time. Meanwhile, your machine is waiting for this. And as soon as you make the request, it sends back an answer. And so now your computer is sending the request to the wrong domain name server. Another problem, of course, is just poisoning the domain name server. You can send the domain name server address. Domain name servers talk among themselves. And if they're sending false information, that could poison the information in the domain name servers. There are security systems now to do this that use signatures, digital signatures, public key infrastructure to send information so they can validate where it comes from. But you have to use those. Almost everybody's domain name server now does this because there's been some big problems. Some of the domain name servers took out the addresses for like Amazon. And everybody's, well, particularly over the pandemic, everybody was shopping on Amazon. But it wasn't working in certain areas of the country because the domain name servers in that place have been poisoned. They were sending things to the wrong place, or they were sending them off to places that don't exist. But there are now security extensions to that to keep that from happening. Okay, any questions about networks, webs? There'll be no web-oriented or network-oriented problem that doesn't have anything to do with security. And you'll not be required to write HTML unless, if you're a certificate student, but if you're an undergrad or maybe a master's student, be prepared. Okay, cross-site scripting is where you hide some JavaScript in the input and its interpret. Again, one of the major sins is to ever interpret user input. It's cross-site request forgery, cross-site scripting, SQL injection. The big problem with all of these is at some point, it's going to interpret what you enter. If you're concatenating the user's input into a string that SQL is going to interpret, or you're putting it into a command that HTML is going to interpret, you're going to have problems. So you got to keep these systems from interpreting the user input as if, if it's text, it's fine, but if you start putting JavaScript or other script in there, you're going to have problems. So here's the example I had. We have a website that asks you for your name, it sends it off to the other side. And then it responds back, hello with your name. Easy enough. But let's just say, instead of sending your name, I put bracket script, ending with the end script, and all HTML commands. Everything starts with things greater than a list in brackets with a keyword here. By the way, no space between the bracket and the first letter. That causes problems. So you say script, and at the end, so if you start a paragraph, it's bracket, P bracket, everything in that paragraph ending with bracket /P. Slash says this is the end of that term. So they have to match. They're supposed to match. Actually, HTML is very tolerant of messing up. There are all sorts of systems that will read your HTML and tell you if everything balances nicely. But there's a whole bunch of websites out there that don't work well, but still, your browser displays them as best they can. Anyway, So if you put script alert in here, it'll pop up a box. Now you can do a lot more than put alerts in there. I've been doing alerts because it's very obvious when you do it. You can see, aha, the box popped up. You can see that it did something other than just take your name. And it's benign. You do the alerts, nobody gets hurt, just pops up your name. You can do a lot more. You can put all sorts of JavaScript in there. It might be very long. You might work on this big JavaScript program, or you might have a JavaScript where you pull in the script for another website. You can put a file.js out on a website, and then in the script statement, you can say the source is go out over here. So what you enter isn't very big, but it executes this big JavaScript program, and who knows what it will do to you. Yes, sir.
So JavaScript forms the actions in HTML is like the structure of the website.
Yes, with HTML, basically describes what's going to appear on the screen with some information about how it's going to appear. Actually, well, it used to be HTML described what's going to appear on the website and what format it would be. Now they're trying to move the style or the formats into cascading style sheets, CSS files, which tells you, oh, if it's a header, it's supposed to be in this color, in this font. And then you just say in HTML, I want to put the header here. And then the browser looks in the style sheet, finds out what file. And then the JavaScript, though, is where they actually, it's a programming language where you can take the information, do whatever you do with programming and do whatever calculations you want done, send information off to the server, get information back and display it.
PHP is a database language.
Well, PHP is a language that often runs on servers. Many web applications have HTML and JavaScript running in your browser, and they're communicating with a PHP program on the server. And it can do whatever you want to in the PHP program. Many web applications need to get information from a database. And so you can access the programs with PHP and say MySQL. Now, there's other languages you can use besides PHP. And my humble opinion, PHP is a pretty miserable programming language. There are better programming. You can use Java itself, or JavaScript. Both of those can be used on the server. There are systems that allow you to use, or you can use C++ or whatever you like. There are multiple languages you can use. PHP is very common. Again, I don't particularly like PHP, but you're talking to the guy who teaches the programming languages class, and we analyze programming languages, well, what's good and what's bad about it. And there's a bunch of things on the negative side for PHP. So if you really want to do a good job, I'd write the server side in something better than PHP, but it's so common. There's so much support and packages that work for it. You can do that in PHP. Okay. Got the idea with that? That's a good question. All right. HTML has some checking you can do. Whenever you have these text fields, whenever you have a form, if you say you have a form in HTML, it puts those little boxes. You say, this is an input, I want a box here, I want to say this. And you can also specify what type of input. Is this text input? Is this a number? Is this a date? Is it an email? Is it a URL? And it will check to see that what you typed in looks like a good email address or URL. If you say email address, you better put an @ sign in the middle because it's not going to work otherwise. If you say it's supposed to be a number, it will only allow you to enter numbers. If you try to enter something, it also, yeah, we have a question? Comment? I guess not. Sorry. If you have a number field, you can specify the minimum and the maximum value. This number cannot be smaller than this, can't be bigger than that. And there's other things you can specify. Now, you can also do pattern matching, say the input has to match this pattern. You get really fancy with regular expressions. Note that while it checks that, it won't do anything about it unless you call the functions saying, is this good? Of course, if it's not good, then you do something in your program about that. There are two versions of the functions, one that just returns true and false. Yes, this looks good, and no, it doesn't. And the other one says yes and no, and will display a message if it doesn't look good. Okay. Cross-site scripting comes in two flavors, persistent and non-persistent. Non-persistent is often referred to as reflected. The example I gave before, it was reflected backing up. Yes, here, I sent it off to the website and it sent it back. It's reflected. It tends to come back to that same user. That may seem like you're shooting yourself, but you can also cause your system to do things with what you've sent out. And again, websites can be accessed through links in your email, and the links in your email may not be going where you hope they would go. Here's an example of a link that going to acme.com and usual search thing has got it. No quick. But in fact, that's not really what you want to send. You want to send this. Okay. Persistent ones are probably more dangerous than reflected ones, non-persistent. Persistent ones are where you put something out on a website, frequently a social media website, although almost all the social media companies are well aware of this attack and they watch very carefully to avoid it. So you put data out there, any place where someone's expected to see your name, see the information. If you enter some information and it's going to be displayed, so you enter your name, and on the other player in the game, they're going to show your name. Well, if you enter JavaScript, it will then show the JavaScript on their browser. It will interpret it, do whatever the JavaScript does, grab some information and send it someplace else. So you have to watch out for that. Oh, that doesn't, it didn't display very well on the screen, does it? I wonder what happened there. Okay. Network proxies. We talked about this several times. You can have proxy servers. I mentioned two of them. There's the Burp Suite Community Edition, and then there's the ZAP, the Z Attack proxy. Both of them work quite well, and you can use them to view and edit the information going from your browser to the server and the information going back from the server to your browser so that you can look at what's going on, which is very helpful to learn what's happening. But you can also stop it and change it. If you want to edit, oh, that's not exactly the value I wanted to send. I want to improve that a little bit. It's very important to remember that even if your browser very carefully validates all the input, it's not much good if the user, excuse me, if there's a proxy in the middle, it may be one that you have or maybe another one that's modifying the values. So say you're running the Burp Suite and you're using your website, the browsers very carefully, making sure you don't do anything nasty. So you send it, it sends the packet off to the server. Yeah, but you stop it in the middle, edit it the way you want it, and then send it on. So no matter how careful the browser or the JavaScript or the HTML check the input, somebody can change it anyway. Here's an example of parameters. If you notice, this website's got the price stuck up there. And so it's when you click on it, it sends the price. Well, you can stop that with proxy, or you can even stop that with the debugger. You do the debugger before you send it. You'll have to edit that a little bit. By the way, when you're using the debugger, you want to set a breakpoint and wait for it to stop, because most of the variables are inaccessible until the program has stopped, because they're in flux, they're changing. You can't modify these things while they're changing. Debuggers don't work that way. Debuggers wait till it stops, and then you can look at the variables and change them. So in the debugger here, you could change this value, or you can change it with HTTP both ways. Say, oh, there's a constant, and change that. And then there's a problem with putting sequential numbers in there. Watch out for sequential. If somebody's using it, in this case, it's a relatively small number. You might guess, well, what's order number 2458 or what was 2456? An easy way to solve that is use big numbers. Don't use that. And use a random number generator. There's a lot of random number generators that'll give you full 32-bit random number. And you just have to keep track of what the last random number was. You then use that as a seed to your random number generator. It gives you the next one. So whenever you need to generate the next order number, instead of just incrementally counting, you go through a random number generator and it gives you a big number. Somebody will not be able to guess what number to use if they're somewhere between 0 and 2 billion. So the probability of them guessing correctly is much, much smaller when you're only using a couple thousand of those numbers. You can do the chances are 1,000,000 to 1 that they'll guess the right number. So, or if you want to be really careful, you can append to the number just a number and a checksum, and then encrypt the checksum, or encrypt the checksum in the number. Instead of, remember, if this is information coming from the server creates this, sends it down to the browser sends it back. So the browser doesn't have to know anything about how that number is. It's just bits. They collect the bits, they send the bits back. Those bits, if it's a number that's been encrypted or has a hash that's been encrypted, you're not going to be able to change it without the hash not working. Was there a question online? I guess I don't hear one. Okay, moving on. Hidden parameters. You can say type number, type text, type date, type hidden. Hidden means it doesn't show. It is not displayed on the screen. But when you press submit to send the data to the server, it sends additional information backing up. In this case, the price. The price, well, I guess the price does, but it's not an input field in there. It's just sent. It would be a hidden field in the form. So you can send information. You gotta be careful because, of course, again, a user can change that either with the browser debugger or with a HTTP proxy. There's many different types. Normally you see text or number or date or URL or email address. There's W3 Schools, by the way, is my favorite source for learning how these things work. Go out there and find out. Yes, if I want to know about how web pages work, I look at w3schools.com. If I want to know about how the securities work, I look at Wikipedia. It'll work for you. Clickjacking, I think this is the last topic. It's good because we only have like 2 minutes left. And clickjacking is where you put one page over another. Use an iframe to hold the victim page in there so it looks just like it is the victim's page showing there. And it will work just like the victim's page because it's connected to the victim. Whenever you click on something, it goes out to the victim's website. But you can overlay things. You can overlay transparent things, things that the user can't see. You can put your buttons on top of their buttons. So when they click on what they think is the buttons for the safe and friendly website, in fact, is going to your stuff. I like this picture. It shows you here where the evil website is on top of this A&T, and where they might have a button on the trusted website. When you click it, you're going to go to the evil website. Questions about that? I had some examples. I'll make those examples available online. All right. Exam is 2 days from now. It's again starts at 6 a.m., goes till midnight, online for everyone. How big is it? Oh, I don't know. Probably about 10 questions. I think I have 9 or 10 questions written so far. I'm getting tired of writing questions, so that may be it. It will cover the topics that we've covered. Anything we've covered in class could be on the exam. Anything you might have read in the book won't be on the, if it's not, did not covered in class, it won't be on the exam. Remember, I don't want long answers. I got to read these things. Last exam was obvious that people were going out to websites, copying and pasting back in. Now, you can still do that because it's an open web, open book, but it has to be no longer than 5 sentences, no more than 75 words. If it is, we will start taking points off. TAs just love taking points off. So that's, any questions about the exam? Again, it is on Wednesday. Oh, there will be no class on Wednesday. Yes, unless people want to do online talk with me on Wednesday at 4:30. That wasn't very fruitful, I didn't think, last year. If you want to meet me at 4:30 on Wednesday, send me an email and say you do, and I'll be there. Otherwise, we will not have any meeting on Wednesday. If somebody wants to meet with me at 4:30 on Wednesday, we'll meet with everybody. Of course, at any time during the exam, you don't understand what the question asks, email me, text me, something, and I'll try to respond as quickly as I can.
So you said, and like the exam will be based on assignment that we give, so we will have form actions.
Yes, there will be some perform actions like login, SQL injection. There is an SQL injection problem. Be ready for that. It's going to be out there. There's some others like that. I will not require any of the certificate students to write HTML. Now, if you're an undergrad, you probably know that stuff. You ought to know that. Be ready. Okay. Any other questions about the exam? If you do, send me an email, send me a text, and I'll try to respond as quickly as I can. Good luck on all your exams. Hang on,